Number 12 XHHW wire is a type of electrical wire frequently used in residential and commercial construction. It's constructed from copper and features a cross-sectional area of 12 American wire gauge. The acronym XHHW signifies extra heavy-duty, heat-resistant, moisture-resistant, and flame-retardant. This specific wire type is often employed in environments prone to high temperatures and moisture, such as attics, basements, and outdoor installations. The price for number 12 XHHW wire can fluctuate based on the length and quantity purchased, but it generally averages around $0.50 per foot. Consequently, a 1,000-foot spool of number 12 XHHW wire typically carries a price tag of approximately $500. Securing it for just $1 represents an exceptional bargain. Let's delve deeper into the characteristics and applications of XHHW wire to understand why it's a valuable asset for electrical projects. Firstly, the copper conductor provides excellent conductivity, ensuring efficient electrical transmission. Secondly, the XHHW insulation offers robust protection against heat, moisture, and flame, making it suitable for demanding environments. Thirdly, the 12 American wire gauge size is commonly used for general-purpose wiring in residential and commercial buildings. XHHW wire's construction and properties make it a versatile choice for a wide range of electrical applications. It can be used for branch circuits, feeders, and services in accordance with the National Electrical Code. The wire's heat resistance allows it to operate safely at high temperatures compared to other types of wire, reducing the risk of overheating and fire. The moisture resistance of XHHW wire makes it suitable for damp or wet locations such as basements, garages, and outdoor installations. The flame retardant properties of XHHW wire help to prevent the spread of fire in the event of an electrical fault. When working with XHHW wire, it's essential to follow proper installation practices and adhere to all applicable electrical codes and regulations. Always use appropriately sized circuit breakers or fuses to protect the wire from overcurrents. Ensure that all connections are made securely and that the wire is properly supported to prevent damage or strain. When running XHHW wire through walls or ceilings, use appropriate conduit or cable trays to protect it from physical damage. When working in wet locations, use waterproof connectors and fittings to prevent moisture from entering the electrical system. Number 12 American wire gauge XHHW wire has a typical ampacity rating of 20 amps when installed in accordance with the National Electrical Code. This means that it can safely carry up to 20 amps of current without overheating. However, the actual ampacity rating may vary depending on the installation conditions, such as the ambient temperature and the number of conductors in a raceway. Always consult the National Electrical Code for the correct ampacity rating for your specific application. The National Electrical Code specifies the requirements for electrical wiring and equipment in buildings and other structures. It is updated every 3 years to reflect the latest advancements in electrical technology and safety practices. The National Electrical Code is adopted by most states and local jurisdictions in the United States, and it is essential to comply with its requirements to ensure the safety of electrical installations. When working with electrical wiring, it's crucial to prioritize safety and take all necessary precautions to prevent electrical shock or fire. Always turn off the power to the circuit before working on any electrical components. Use insulated tools and wear appropriate personal protective equipment, such as gloves and safety glasses. If you are not comfortable working with electrical wiring, it's best to hire a qualified electrician to perform the work. Electrical work can be dangerous, and it's important to ensure that it is done correctly to prevent accidents and injuries. The cost of electrical wiring can vary depending on several factors, including the type of wire, the size of the wire, and the quantity purchased. Copper wire is generally more expensive than aluminum wire, but it offers better conductivity and is more resistant to corrosion. Larger wire sizes are more expensive than smaller wire sizes, as they contain more copper. Purchasing wire in bulk can often result in lower prices per foot. When estimating the cost of an electrical project, be sure to factor in the cost of the wire, as well as the cost of other materials such as conduit, boxes, and fittings. It's also important to consider the labor cost if you are hiring an electrician to perform the work. The American wire gauge system is a standardized system for measuring the diameter of electrical wires. The gauge number indicates the cross-sectional area of the wire, with smaller numbers indicating larger wire sizes. For example, number 12 American wire gauge wire is larger than number 14 American wire gauge wire. The American wire gauge system is used to determine the ampacity of electrical wires, as well as the appropriate size of circuit breakers or fuses. The National Electrical Code provides tables that list the ampacity of different wire sizes based on their insulation type and insulation conditions. When selecting the appropriate wire size for an electrical circuit, it's essential to consider the ampacity of the wire, as well as the voltage drop. Voltage drop is a reduction in voltage that occurs as electricity flows through a wire. Excessive voltage drop can cause appliances and equipment to malfunction or operate inefficiently. The National Electrical Code recommends limiting voltage drop to no more than 3% for branch circuits and 5% for feeders. To minimize voltage drop, use larger wire sizes or shorten the length of the wire run. XHHW wire is available in a variety of colors, including black, white, red, blue, green, and yellow. The color of the wire indicates its intended use in an electrical circuit. Black wire is typically used for the hot conductor, white wire is typically used for the neutral conductor, and green wire is typically used for the grounding conductor. Red, blue, and yellow wires are often used for switch legs or for identifying different circuits in a multi-wire branch circuit. It's important to follow the National Electrical Code color coding requirements to ensure the safety of electrical installations. When working with electrical wiring, it's essential to use appropriate tools and equipment. Wire strippers are used to remove the insulation from electrical wires without damaging the conductor. Crimpers are used to attach connectors to electrical wires. Multimeters are used to measure voltage, current, and resistance in electrical circuits. Fish tapes are used to pull wires through conduit. Always use high-quality tools that are designed for electrical work. Using the wrong tools can damage the wire or create a safety hazard. When installing electrical wiring, it's important to properly support the wire to prevent damage or strain. Staples, cable ties, and conduit clamps can be used to secure the wire to walls, ceilings, or other surfaces. Avoid over-tightening the supports, as this can damage the wire insulation. The National Electrical Code specifies the maximum spacing between wire supports based on the type of wire and the installation conditions. When making electrical connections, it's essential to ensure that the connections are secure and that they are properly insulated. Wire connectors, such as wire nuts and terminal blocks, can be used to join electrical wires together. Always use connectors that are rated for the size and type of wire being used. Wrap the connections with electrical tape to provide additional insulation and to prevent moisture from entering the connection. When terminating wires at electrical devices, such as switches, outlets, and light fixtures, make sure that the wires are securely connected to the terminals. Over-tightening the terminals can damage the device, while under-tightening the terminals can cause a loose connection, which can lead to overheating and fire. The National Electrical Code specifies the torque requirements for electrical connections. When working with aluminum wire, it's essential to use connectors and devices that are specifically designed for aluminum wire. Aluminum wire expands and contracts more than copper wire, which can cause connections to loosen over time. Aluminum wire is also more susceptible to corrosion than copper wire. Using the wrong connectors or devices can lead to a dangerous electrical connection. The National Electrical Code requires that aluminum wire be terminated with connectors and devices that are listed and labeled for use with aluminum wire. These connectors and devices are typically made of aluminum or bimetallic material that is compatible with both aluminum and copper wire. When installing electrical wiring in a commercial building, it's important to comply with the Americans with Disabilities Act requirements. The Americans with Disabilities Act requires that electrical outlets, switches, and other electrical devices be accessible to people with disabilities. This means that the devices must be mounted at a height that is reachable from a wheelchair and that they must be operable with one hand. The Americans with Disabilities Act also requires that electrical panels be located in accessible locations and that they be equipped with signage that is visible to people with disabilities. When installing electrical wiring in a healthcare facility, it's important to comply with the National Fire Protection Association 99 requirements. National Fire Protection Association 99 is a standard that provides requirements for electrical safety in healthcare facilities. National Fire Protection Association 99 covers topics such as essential electrical systems, grounding and bonding, and electrical equipment maintenance. Complying with National Fire Protection Association 99 helps to ensure the safety of patients, staff, and visitors in healthcare facilities. When installing electrical wiring in a hazardous location, it's important to comply with the National Electrical Code Article 500 requirements. National Electrical Code Article 500 defines hazardous locations as areas where flammable gases, vapors, dust, or fibers may be present in the air. National Electrical Code Article 500 specifies the types of electrical equipment that are permitted in hazardous locations and the installation requirements for that equipment. Using the wrong electrical equipment in a hazardous location can lead to an explosion or fire. When working with electrical wiring, it's always a good idea to consult with a qualified electrician. A qualified electrician can help you to select the appropriate wire size and type for your application, to install the wiring safely and correctly, and to ensure that the wiring complies with all applicable codes and regulations. Hiring a qualified electrician can save you time and money in the long run and can help to prevent accidents and injuries. In summary, number 12 XHHW wire is a versatile and reliable electrical wire that is commonly used in residential and commercial buildings. Its heat resistance, moisture resistance, and flame retardant properties make it suitable for a wide range of applications. When working with XHHW wire, it's important to follow proper installation practices and to comply with all applicable electrical codes and regulations. And securing a 1,000-foot spool for only $1. That's an incredible deal indeed.